Have you ever wondered how a computer, a seemingly lifeless machine, can perform complex operations that even humans struggle with? It all comes down to the magic of computation theory. Flashback to ancient times when our ancestors used rudimentary devices like the abacus and tally sticks to perform calculations. These were the first computational tools, and they laid the groundwork for the complex machines we use today. Fast forward to the 19th century, the era of mechanical computers. Charles Babbage and Ada Lovelace designed machines that could perform mathematical calculations using gears and levers. These machines, though never fully realized in their time, were the precursors to modern computers. But the real game changer came in the 20th century with a man named Alan Turing. Turing, a British mathematician and logician, is often hailed as the father of modern computer science. He devised the concept of a universal machine that could compute anything that is computable. Known as the Turing machine, this abstract device became the blueprint for all future computers. Now let's delve deeper into the world of computation theory. The first stop is deterministic finite automaton, or DFA. A DFA is a theoretical machine with a limited set of states. It reads a string of symbols, moving from one state to another based on a set of rules. DFA is deterministic, meaning it has a unique next state for every pair of state and input symbol. Next in line is the non-deterministic finite automaton, or NDFA. Unlike DFA, NDFA is not deterministic. It may have more than one next state for the same state and input symbol. This gives NDFA the power to explore multiple computational paths simultaneously. Moving on, we encounter the push-down automata. This machine is like a more powerful version of the finite automaton. It has an extra feature, a stack, which provides additional memory. The stack allows the machine to remember an arbitrary amount of information, which makes it capable of recognizing more complex patterns. Finally, we return to the Turing machine. A Turing machine is like a push-down automata with an infinite amount of memory. It can read, write, and move along an infinite tape, performing any computation that can be described algorithmically. To wrap up, we've journeyed through the history of computation, from the abacus to the Turing machine. We've explored the DFA, NDFA, push-down automata, and seen how each machine builds upon the previous one, adding more capabilities and computational power. Remember, behind every click, swipe, or voice command on your digital devices, there's a world of computation theory working its magic. So, the next time you use your computer or smartphone, give a nod to Alan Turing and the pioneers of computation. They've made our digital age possible.